In the lab we're going to do today, we are going to look at the density of solids and liquids. And so to do this, you are going to print the laboratory procedure and you're going to handwrite the boxes in the sheets. And you can find the laboratory procedure here. You can download it and then, of course, print it. For whatever reason, it's taking just a hot minute there to pull up. And so we can see it here. Now, when we look at this, which we're going to look at this together in a second, I already have it downloaded and pulled up over here. The lab you're going to use is the Density Lab and Beyond Lab, the Beyond Lab portal. And so we can see it loading here. This lab configuration restored is what you're going to look for. I did this earlier today and it had a problem uploading in the lab, and so I just reloaded it. So if you run into a problem, just go ahead and reload it. So let's look at this density lab together. So the objective here is to learn how to find the density of solid objects and liquid objects. So we're going to work with both. Density is a concept that we experience regularly, but very rarely do we actually have to measure it. It's just common to pick up an object and note that it's heavier than what you would expect for the size, or to see an object floating in a liquid and be surprised that at how it floats up in water. I feel like there's a typo there somewhere. I experienced this recently. I ordered some ethanol for the lab, and there were 600 milliliters, and I picked it up expecting it to be like 600 milliliters of water and really heavy. And ethanol is the density of ethanol is like 0.79 grams per milliliter, where water is 1 gram per milliliter. So it was not anywhere near as heavy as I expected. And so even though I've been working with science and density for a long time, density can still surprise me. When I first got into the lab, we had some mercury in some jars, and I picked up mercury thinking it was going to be as heavy as water. And mercury, of course, its density is much larger than water, and I was very surprised and shocked. So this is something that we run into quite frequently and can be surprising and shocking. So they talk about like comparing densities and how does the density of water compare to iron, or the density of styrofoam compared to seawater. So what we're going to look for here and really investigate is density, mass, and volume. And as we mentioned in the class, we can calculate density by taking the mass and dividing by the volume. And you can see density equals mass over volume here. And you can also see the symbols that are used to represent both mass and volume here. Now, to be able to calculate the density of a material, you need to know both the mass and the volume. And there's a lot of different procedures you can get to find the volume of a solid. You can find it by measuring the dimensions of the object. If it's kind of an easy shape, this most likely is not how we do it in chemistry. The more common way to do this in chemistry is we're going to use a procedure called fluid displacement, where we're going to measure how much the liquid of the object moves out of the way when it's submerged. So we're going to take the differences in volume there. So for this assignment, you're going to measure the volume of a solid and the volume of a liquid in milliliters. And a milliliter, I just want to remind you, is defined as a centimeter cubed. Okay, so volume are generally shown as cubes. So the unit for density in this lab is grams per milliliter. Sometimes in the book, though, you're going to see grams per centimeter cubed. And so I just want you to be aware of that. Also, because we have a focus on nursing in this class, I want to remind you that a centimeter cubed is also equal to 1 cc. So just kind of be aware of that. So you're going to ask you're going to answer the pre-lab questions here. You can write in the box or write below here. Either one is fine. Now remember, this is a PDF, so you will not be able to open it using the link here, but you're going to use the link on Canvas, and it's going to open in a new tab. Now it says drag the plastic ball from the wall. So when we look at this and we get into this lab, I want you to notice several things. The balls on the wall are shown here, and there's a lot of different ones, and so you need to hover over them to see what they are. This is aluminum, this is a brick, this is red oak. And you're going to find the plastic one right here. And so this is plastic. Now, you can hold down your cursor and pick it up and move it around, right? And so if you want to move it to a graduated cylinder, you can move it here, okay? I want you to notice that this is filled with virtual fluid A here, right? The graduated cylinder. And so when you want to drop the ball in, all you have to do is hit drop, okay? And that will drop the ball in. And so if we go back here, it says you're going to drag the plastic ball from the wall. You need to go to the balance first and record the mass. And so I went directly here, but you can also go to the balance here. So, and then I'm going to put the plastic ball back there. So you can see that as well. So you're going to drag it, you're going to record the mass on the table. The sample name here will be plastic ball. Then what you're going to do is you're going to put the plastic ball on that 250 milliliter graduated cylinder. And then you're going to drop the plastic sample and release it into this cylinder. And so you're going to do that using this kind of drop button here. Then you are going to record the new volume, right? And then you can click the blue handle at the bottom to empty the contents of the cylinder. And that blue handle is right here where you can empty that. And so you're going to answer these questions. And then here's your second procedure. So in your second procedure, we're going to focus on a liquid. So the first procedure was the density of solid, and now we're going to look at the density of a liquid. And the liquid we're going to look at is ethanol. And so you can come over here and you can see ethanol here. And so you can select that. And so just the way you do that is you click here. Well, oh, I didn't drain it out. So you drain it out, right? And then you can select ethanol. If you don't drain it out, apparently you cannot select ethanol. So it will automatically fill up again. So just kind of be aware of that. And what this says is you can drag the beaker from the counter to the spotlight on the balance. So again, if you want to drag, you just click here, and then you can click and hold and drag this around. You can put it on the balance there. So just kind of be aware of that. About that, if that broke up for just a second, it's because I was so excited about dragging the graduated cylinder everywhere that I hit the pause button on the side. Okay, so once you do that, then you need to answer the rest of the questions and upload this into Canvas. You do also need to do an extension activity where you're going to test a hypothesis, and you're going to drop the plastic sample into the ethanol and see if it sank or float. And then you need to write a short description of your observations here. I want to remember that when you're writing in science, you need to write incomplete sentences. Same thing here. Here, anytime you're explaining your answer, these need to be incomplete sentences. Have a great day.